Good evening. Is it audible? My sound is clear to everyone. So this is June 2023 paper. Last we discussed question 1 and 2. Today we'll do question 3. And then unit 5 topic wise questions we'll do, and then the explanation of unit 4 and the questions from unit 4. So question 3, a student investigated the bending of investigating the bending of a flexible wooden beam, as you can see here. A student placed a load on a wooden beam. The center of the beam was displaced by a distance d, as you can see here, that it was originally at this position. When a load is placed, it has displaced. So how much it has displaced from the original position, that distance is d. The length of a beam between the supports is L. Describe an accurate method to determine a single value of a d by using a 15 centimeter scale ruler. You should include any additional apparatus. So if we want to measure the height, we want to measure the length. So, and by a single measurement, like we keep the position same. And then what we can do, like we can place a 15 centimeter scale here. So we place a 15 centimeter ruler or 15 centimeter scale. And additional apparatus, what we can use a set square. So first a 15 centimeter scale or a 15 centimeter ruler, and next to that we'll place a set square. So measure we'll measure the initial reading, like the starting before we add a load, we measure that reading. And once we add a load, we'll measure the final reading. And we'll take a difference to know what is this value of a D is there. So describe an accurate method to determine a single value of a D using a 15 centimeter ruler or 15 centimeter scale. So how we can determine? So we can record the initial position, and we can of initial and the final position of the center of the mass. And then by using a 15 centimeter ruler and the set square, and the 15 centimeters ruler should be placed vertically at the center. So the points here, so we will place 15 centimeter ruler vertically at the center of the beam. Then use set square. Then we'll measure the initial position of center of mass. And the final position of center of the mass. And then how to work out the value? We just subtract the two values, subtract to find the value for D. So when we subtract the two values, we'll get the value for D. The next is student varied the L between the support, and she used a vernier caliper to measure a displacement for a load. She records the following data. As you can see here, the data is there. Then plot a graph for log D and log L. So what you have to do, you have to, on the grid opposite, and new additional column for, so L value is given, D value is given. So you have to take a value for log D. And whenever you write your answer, especially for logarithm, it's better write 3 decimal places. Okay, when you're taking logs, write the answer to three decimal places. So we have log L is there and the unit is meter, and we have log D is there and the unit is also log of D slash meter. So you just have to use your calculator, like take a log of like 0.95, 0. And this will give you a negative answer, like because the log values are negative when this is less than 1, it will be negative. So all the values will be negative. For log L, the values will be negative, and the log D, the values will be negative. So then we have to plot a graph for log D against log L. So we have to use a negative y-axis and we have to use a negative x-axis. So, and they mention here log D. So because, so where we will plot this on the opposite grid. So example, if you the first one, if you're plotting on y-axis, the second one you plot on x-axis. But because of both x and y values are negative, so how you'll plot this result, the graph? You have to use a negative x-axis and you have to use a negative y-axis. So this time, when you draw the x-axis, like x and y-axis, because say this is a grid. Here we have, in this region, we'll have a positive x-axis, positive y-axis. In this region, positive y-axis, negative x-axis. And here, negative. So this region, we have to plot a graph. We don't have any positive value. So how we'll take our axis? We'll take, this is negative x-axis, and this will be negative y-axis. And here we'll have a 0, 0. A negative value of x-axis and a negative value of y-axis. And they should be on opposite grids, as I mentioned here in the question. So example, this is log D is there, and the other one is log L is there. Because both are negative and there will be a linear relation, so the graph will be somewhat like this. Because I'm not plotting a graph, I'm just explaining the idea. It won't start from origin, it will be somewhat in this manner. Then determine the gradient. After plotting a graph, you have to use your graph to determine the gradient. Take any two values from your graph. And like first value you took, the first value on y-axis, you called y1. First value on x-axis, you will call that as x1. And the distance between the 2 points when you take for gradient, that should be more than 5 centimeters. So this will be y2 and this will be x2. So you will use a formula, gradient is y2 minus y1 over x2 minus x1. That will give us the gradient. Then it is suggested that for a given load, the relation between the D and L is in this form, where R and K are the constants. Determine the value of a K from your graph, hence write the mathematical relation between D and L. First, we have to modify this equation. How we'll modify this equation? Because the power is there. So if we take log both sides, so this will be log D is equals to K. So it will be equals to log K L raised to power R. Then this will remain log D, but when two quantities are multiplied, like K and L are multiplied, so in log, when two quantities are multiplied, we write them as addition. So it will be log K plus log L raised to power R. And whenever in a log ln or a log, if there is a power, this will turn to be a coefficient. So this will become R log L. So if you modify this equation, log D is equals to log K plus R log L. And then if we rearrange, because on our graph, we plotted log D on y-axis and log L was on x-axis. So if we rearrange the equation, like we only change the order, so it will be log D is equals to R log L plus log K. Then Y is equals to mx plus C. On y-axis, if we have log D, on x-axis, if we have log L, what will be our gradient? So our gradient will be equals to R. So when we actually calculated the gradient in the previous part, that is representing the value of R. And what about, then we have to determine the value for K. What is value of a K? The value of a K is log y-intercept, like log K is y-intercept. So what you have to do, like this was your graph. When you plot the graph, your graph will be somewhat like this. How to work out the y-intercept first? So you continue your graph, you extend your graph until it intersect the y-axis. The point, the position where it intersect the y-axis, that is called y-intercept. And this y-intercept is equals to log k. So value of the y-intercept according to the graph will be equals to log k. You need k, so you will take anti-log. So when you take the anti-log, you will get the value for the k. How to take anti-log? Like say this value was say any number, it can be say 1.73. Y-intercept, for example, minus 1.73 was there. And this is log and k. You need k, so take anti-log. How to take anti-log? Anti-log means like 10 raised to power minus 1.73. On your calculator, scientific calculator, just press shift and the button for log. It will take an anti-log and that will give us the value for k. Is it clear, this one? So when they said mathematical relation between L and D, it means you have to just rearrange this equation. So this was question 3. Every session we'll do a question from unit 6. So it will be a practice. And as I mentioned, for unit 6 preparation, I shared the notes with you. But the best way to prepare unit 6 is doing the papers directly. Because you will find variety of question, different concepts are there used in paper 6, and it's not like you will learn only in one day. It's like you will learn with the practice. So best way to do paper 6, unit 6 is do the papers.